Assalamualaikum warahmatullahi wabarakatuh. We are from Group E. My name is Muhammad Firdaus bin Muhammad Kumirifin. Our group mate consists of Balkis binti Muhammad Zamulut, Flodiah Rain binti Bidan, Muhammad Syahir Naim bin Alias, myself, and Nurul Shasha Izzati binti Mansur. So, Group E, our group will be discussing about question 1, and we prepared to you two method or two solution. I'll be talking about method 1, and Shahina Im will be talking about method 2. Okay, so let me read the question first. So the question said, use Grimm's theorem to verify that the line integral of c y squared x plus x squared dx plus 4x minus 1 dy equals to 99/4, where c is formed by vertices 0, 0, 0, 3, and negative 0 oriented counterclockwise. So I will proceed to method 1. So firstly, we sketch the graph according to the point given 0, 0, 0, 3, and negative 3, 0. We got a right angle triangle. So in here we find the hypotenuse, the equation of the hypotenuse. We got y equals to x plus 3, and we put out the boundaries. We got x is less than or x is more or x is greater than or equal to negative 3 and less than or equal to 0, and then y is greater than or equal to 0 and less than or equal to x plus 3. After that, from the equation given in the first question, we got p dx and q dy. From that, we verify both of them. So we derive both of them. So firstly, we derive y square x plus x square with respect to y. We got dp dy equals to 2yx, and then we verify we derive 4x minus 1 with respect to x. We got 4. So and we got dp dy, and we got the value of dp dy and dq dx. So from the value given, we substitute the value into the Green's theorem equation. So from this, we got the double integral for minus 2xy dx dy. So the double integral, we have to put the upper limit and the lower limit for the integral. So the first integral with integral with respect to the integral dy, we put the upper limit x plus 3 and the lower limit is 0. And the second integral, we put 0 as the upper limit and negative 3 as the lower limit. So we got 0, negative 3, x plus 3, 0, in bracket 4 minus 2xy dy dx. So we integrate the first integral, which conclude x plus 3 and 0 as the upper limit and the lower limit. We integrate the equation, and then we got 4y minus xy squared in bracket x plus 3, 0. So we substitute the value of y, which is x plus 3. We got x in bracket x plus 3 minus x in bracket x plus 3 squared minus 0. So in the bracket, first we simplify the equation. We got negative x cubed minus 6x squared minus 5x plus 12. So at this point, we need to do the second integral, which is integral 0, negative 3 in bracket negative x cubed minus 6x squared minus 5x plus 12 dx. So basically, we do the same integral as the same process of integration. We got negative x power 4 over 4 minus 2x cubed minus 5x squared over 2 plus 12x in bracket upper limit 0, lower limit -3. So we substitute 0 first because 0 is the upper limit. So since in all numbers we have at least one unknown which is x in it. So when we substitute 0, we got 0. So 0 minus, we substitute -3 as the x value into the equation. We got in bracket -81 over 4 plus 54 minus 45 over 2 minus 36. With simple addition, subtraction, multiplication, division process, we got 0 minus negative 99 over 4, negative positive, we got 99 over 4. So 99 over 4, basically the answer is given in the sort of question.
Okay, so my name is Muhammad Shahin Naim bin Alias. My metric number 208200. So I'm going to explain to you for the method 2. Alright, so firstly, we need to do the same as the previous one. We need to sketch the graph using the point given, which is the 0, 0, 0, 3 and -3, 0. Alright, so now we use type 2. The first one we use the type 1. So for this time we will differentiate the with respect to x first, while the first one we need to differentiate with respect to y first. Okay, so the limit is x is larger or equal to y y minus 3 and less than or equal to 0. And for the y is larger or equal to 0 and less than or equal to 3. So next, right, as we can see, the integration of c p dx plus q dy. So we will double integrate with the region of del q del x minus del p del y, which with respect to the x dy. And so for the p equation, y square x plus x2. So we're going to differentiate we call it del p del y. So it is equal to 2yx, while for the q we need to differentiate with respect to x, so it will become del q del x, so it's equal to 4. All right, so we substitute in the equation and then we get the double integration for the region 4 minus 2yx dx dy. So we need to set up the limit. So for the first integration with respect to x, we got the limit for the lower limit y minus 3 and the upper limit 0. And the second one with respect to y, we get the lower limit 0 and the upper limit 3. Alright, so the first integration, which is with respect to x dx, so we get the 4x minus y x square. Alright, so we will substitute the limit into the variable, which is x. Alright, so for the first one, 4x minus y x square, we substitute with 0, so it is equal to 0. And for the y minus 3, so we get 0 minus 4 x, we substitute with y minus 3, and then minus y x square we substitute with y minus 3 squared, and dy. So the final answer we get is negative 4y plus 12 plus y cube minus 6y square plus 9y dy. So next, we rearrange to do the second integration with respect to dy. So y cube minus 6y square plus 5y plus 12 dy. So we get the answer y power of 4 over 4 minus 2y cube plus 5y squared over 2 plus 12y. So we substitute the limit, which is 3 and 0, into the variable of y. And we get the answer 3 power of 4 over 4 minus 2 times 3 cube plus 5 times 3 square over 2 plus 12 times 3 and minus with 0 because we substitute the 0 to all the variable y and it is equal to 0. And then we get the answer 81 over 4 minus 54 plus 45 over 2 plus 36. And the final answer is 99 over 4, which we prove that the equation in the question 1 is equal to 99 over 4. So that's all from me. Thank you.